These videos will be for February 3rd, February 6th. What we're looking at are the graphs and transformations along with the key features of quadratic functions. I went ahead and put the definitions for an even function here. Basically, we talked about this briefly with sine, but an even function is a function where f of negative x, this should be f of negative x, equals f of x for all values of x within the domain of the function. Now, I'm going to give an example of what this looks like in a second, but graphically what this means is that even functions are symmetrical about the y-axis. And if you'll give me 1 second. The reason this happens is the reason we're looking at this now is we're looking at quadratics. I'm going to explain what makes quadratic an even function graphically. But here, if we have f of x equals x squared, then what this even function piece and the negative x and positive x is saying, if we take like f of negative 2 and plug that inside of our function, the negative 2 squared, negative 2 times negative 2 would give us positive 4. If we put positive 2 inside of our function, that would be positive 4 as well. So it doesn't matter if it's a positive value, if it's a negative value, does not matter. What's happening is the outcome will be the same. That's what makes an even function. Now, in the previous lesson, we did a brief lesson about the key features of quadratics. I am not including that in the video, but hopefully we can get that as we go along with the graphs of polynomials. Here, what we want to do is transform our function, and then we want to determine the domain, the range, and intervals where the function is increasing, decreasing. We'll wait on minimums and maximums for right now. Excuse me. Let's go ahead and graph this. So the square, well, first off, what we talked about in class is these transformations we know. We know what these transformations tell us. If we subtract inside of our function, that means our function moves to the right 5 units. If we add outside, that tells us we move up 2 units. So I'm going to go ahead and scale my x and y axis. I'm going to go to 6, maybe 7. 1, 2, 3, 4, 5, 6, 7. Now what we have to do is graph our parent function. Well, what is our parent function? The square tells us our parent function and tells us it's a quadratic. Now hopefully you remember from previous classes that a quadratic will pass through 1, 1 because 1 squared is 1, negative 1 squared is 1, and 0 is 0. So this is what our parent function would actually look like for our quadratics. So the square tells us our parent function. And now what we can do is move it to the right 5 and up 2. 1, 2, 3, 4, 5, up 2. 1, 2. And then we draw the function again. So this is what our actual function would look like. Now let's look. We want domain, range, intervals where the function is increasing, intervals where the function is decreasing. Now if we look at the domain, the furthest left our function goes, it will go to the left forever, so our domain here, and it goes to the right forever on our x-axis, would be negative infinity to infinity. If we think about range, we talk about lowest value to highest value. We're talking about y-axis. So domain is x, range would be y. Now let's look. If I'm looking at the lowest value my function takes, the lowest value is here. Where is that on my y-axis? It's 2. So we would say 2, it does touch at 2. And it goes on forever in the y direction, so we say 2 to infinity. That would be our range. So we have our domain and range. These are things we've talked about in the past. What we have not talked about is increase versus decrease. Now I'm going to write interval of increase, underline, boom, boom, interval of decrease. All right, now, and what I think might be helpful here is on the x-axis, if I go forever in the left direction, this is negative infinity, so it might be good to put this out here, positive. It might be helpful on the y-axis as well, negative infinity, positive infinity. Interval of increase, we're looking at the function, our actual function here. And when we read a function, we'll read it left to right. So we're talking about left to right. We're talking about our x-axis. Now this is going to be new, and we're going to continue working on this over the next few weeks. But if we're talking about left to right, interval of increase, what we're looking at is, where is our function? Think about like going up a hill, down a hill. If it's increasing, we're talking about where does our function going uphill? Where is our function going uphill? And if I'm going left to right, I'm here, I'm going downhill along this path, going downhill. Then I make a turn here and I start going uphill. Left to right. Excuse me. So this is where I'm turning. This is the point where it turns. 1, 2, 3, 4. On the x-axis, that's 5. And it increases from here. It makes the turn and it starts increasing forever. Now what's happening is from 5 on this direction, it's going to continue increasing. So our interval of increase is 5. And as we go in this direction on the x-axis, x is going towards infinity. So our interval of increase would be 5 towards infinity, forever. Let's look at decrease. Well, here I'm decreasing down here, and I continue to decrease until 5. So the end, again, on the x-axis, until 5. Now, the x value, where does it start decreasing on the x-axis? Well, technically, this is going to continue going out forever, up and forever, this direction. So we say negative infinity. From negative infinity all the way out here until I reach 5 on the x-axis, my function will be decreasing. Now, what we do here is, now what we need to talk about is, do we have a soft bracket or a hard bracket here? And here's what we talked about. Initially I said, imagine if you were to drop a marble. If I were to drop a marble right here, that marble, like this is a ramp, that marble would go down, and then it'd go back up, and then it'd go back down, up, down, and keep going, and finally sit here at the bottom. Because of that, we say that this is like a flat point, so we do not include 5. Another way to think about it, if we did include 5 here, I'm going to put an X through it. Then what we would be saying is our function increases at 5, also decreases at 5. That can't happen, so that's not true. So our domain, negative infinity to infinity, because it goes forever in both directions. Range from 2 to infinity. Interval of increase, decrease, which we'll continue to get more practice with. 5 to infinity, because as 5 goes forward on the x-axis, our function is going up. Negative infinity to 5, because our function is going down. I'm going to stop the video here. We'll do the next one together, and then I'll probably give you solutions to other functions.